Hello everyone, welcome to NS Codes. Today I'm going to talk about something, well, a little bit controversial. I'm not a real fan of Python, and I'll tell you why I'm not a big fan of Python. I constantly have to read the documentation for everything. It's exhausting. And the reason I have to do so is because Python doesn't have static typing. What is static typing? Why should you care? That's what this video is about. I'm going to show you some code in Python that can crash and why. And you're going to see it's crazy that you're allowed to write this sort of code. Then I'm going to show you some code in C# that can't crash. And the reason it can't crash is because of static typing. And why that's important. I use the word bad actor in this example, but in the real world, code bases get really complex and really spread out. There's code everywhere. You can't know what everything does. And when you have a lot of people on a team, things happen, right? Static typing, if I could speak, helps us avoid these types of issues. It's a lot of talking head. Let's write some code and I'm going to show you what I'm talking about. Hopefully I've got the window and the screen big enough here for everyone. I'm going to try not to scroll too much. I know I've scrolled too much in the past. We have a random number generator for absolutely no reason other than I like random numbers. And I'm going to create a simple class that is only going to do a few things. We will give us a random variable with a seed of 1 for no other reason than I want the numbers to always be the same. Not necessary. And then I'm going to create a method called, I don't know, get random number. I'll even give it a type hint. I can't stop myself with those braces. I'm sorry. Okay, admit this is trivially easy code, right? Okay. Let's go down to the main method. And no, I don't want to go to the main method first. I want to pretend we have some complex code base and get di random class. Tell you, hey, well, maybe we're using dependency injection. There's a complex code base and any appropriate class can be used in this example, but I'm just going to use the one that I wrote right now. And so let's get some class. We don't know what it is. Great. For in range of 1 through 100. We're just going to do this 100 times. And let's print our values and see what happens. Well, I want to do something with it, so let's divide by 0. Or not divide by 0, no, I'm sorry. Divide by 1, 2, 3. So if we have a number, we should always be able to divide any number by 123. That's sort of a known quantity, right? And let's print out that result. What do you think is going to happen? Any guesses? Oh, there we go. We printed out 199 random numbers. I almost said 100. But remember, range, this 100 is an exclusive range, not an inclusive range. So there, we have 199 numbers printed out. Okay, that's great. This worked. Now, 6 months down the line, we hire a new developer and we say, hey, we need a new class written. Write that new class for us. Okay, let's write our new class. I'm going to copy and paste. I'm going to say my bad actor class. And in this class, an error happens. If you're a fan of Stack Overflow, you're probably familiar with the file not found error. So this is a canonical error joke for everyone here. Okay, we have my bad actor class. The exact same code, except, well, now we have a little problem. Now what do you think is going to happen? Any guesses? Well, this is important because this isn't a compile time error. This is a runtime error. Notice the code ran and everything looked correct, and it only crashed when we got the error. This means this code could make it into production quite easily. And in a complex code base, it's easy to see how, because there's no enforcement of the types. And it might be really obvious to the author of, I'm scrolling up, I apologize. So the author of this my bad actor class, they could have a legitimate reason for returning file not found or any other value other than an integer. We don't know what that reason is. Now that we understand that issue in Python, I'm going to demonstrate the code in C# and show you why there's a difference and how there's a difference, and hopefully convince you about why static typing is pretty darn awesome. Now remember, static typing is not the same thing as strong typing. Often static languages are strongly typed, but they're not the same thing. Static means at compile time, the compiler knows what the type is, and that's type safety. All right, let's get started. First things new is in an object-oriented language, we have something called an interface. So we can actually provide an interface for our class. Traditionally, an interface will start with the letter I, the capital letter I. Even in most languages, I think in every language, an interface starts with an I. Now, let's create an interface for that method and define it as a static type that says get random number. So now we know that any class that implements this interface has this type for this method, and it will always be a floating point number. Let's write an implementation of the good actor class. And I want to put the random up here, so we're just going to write some bad code. And now let's implement our interface. Now I am going to, sorry, let's fix the casing here. When we switch languages, most languages have different styles for casing. In C#, it's Pascal case, and I forgot that for a second. All right, let's write our code. And I'm going to do for int I equals 0, I less than 100, I plus plus. And let's get a method to give us this get di class. And it doesn't matter the name. I'm having a lot of trouble right now, and I don't know why. Just because of the names. All right. I'm going to introduce a new concept here, and you see that var keyword. You might think, well, wait a minute, Ennis. If we're using the var keyword, then clearly this isn't static typed. Well, that's not true. What happens is the compiler can guess what the type should be based on the type of this method, and var sum class will always be the appropriate type. For example, if I type sum class equals 1, this is not allowed because we have that actual type. Right? We could be explicit and we could say, okay, let's define the type as sum class, and we'll just do that for now. And let's print, let's do this exact same printing and see what happens. Do we have any guesses on what's going to happen when I compile and run this code? Time's up. There we go. 99 numbers printed. That's fantastic. Okay. Darn. 100 numbers printed. See how the differences in the languages are subtle and they can mess you up? Notice here that I started with 0 instead of 1 as the range function. So this is actually 100 numbers instead of 99 numbers. The little things will always get you. Okay. Now, let's say we have another developer who does our bad actor class, and let's implement that bad actor class and see what happens. I'm just going to copy and paste, save some typing speed, and let's do the exact same thing we did before. Notice some red squiggles, but we're not going to address the red squiggles just yet. I'm going to finish writing the code. Okay, now I'm going to build. I'm not going to run. And you'll notice I cannot build this project or this class file. I can't build any of this code because this red squiggle is not allowed. A string is not a floating point value. Even though we can scroll down, I apologize, I'm scrolling without warning here. We can see down here in the program, the bad actor is allowed to be here because this type is correct. This code is correct. However, the fundamental underlying class is not correct. And we can see here, so we would have to fix this error in order to build this code. And the reason I really like static typing is it gives us that software quality assurance. We know when we write something and it's tested, and we provided those bounds with the typing, it's always going to work. We don't have to write unit tests around those sorts of issues. Whereas if we're in Python, we would need to write significant amounts of unit tests to test the code to make sure those bounds happen correctly. And even then, we're not going to catch the errors like we demonstrated in the example that I'd previously shown. Questions, comments, put them below.